Welcome back everyone. So yesterday we had started with a new chapter, that is chemical kinetics. So let's go for its quick recap. We had studied definition of chemical kinetics. How can we write down rate of a particular reaction? Average rate of the reaction? Instantaneous rate of the reaction? So now, today we are going to study how can we express rate of a reaction graphically. We can express average rate as well as instantaneous rate of the reaction graphically, either in terms of concentration of reactants or products. So now, suppose we draw a graph. On y-axis we take concentration of reactants. On x-axis we take time. So here we will get downward slope because concentration of reactants decreases with time. So if we take initial concentration as C1, final concentration of reactant as C2, for C1 we will have time T1, for C2 we will have time T2. The difference of T1, T2 will be delta T. The difference of C1, C2 will be delta R, and this slope, this downward slope is rate average, which is equal to minus delta R upon delta T, which is equal to minus C2 minus C1 T2 minus T1. Now, in this graph only, if we want to express instantaneous rate of the reaction, then we have to consider a particular time t, right? We'll draw a tangent here and enclose it in a form of a triangle. This is dr. This is dt. And this area is rate instant, which is written as minus dr upon dt. So minus slope will be rate of the reaction, that is instantaneous rate of the reaction. Similarly, if we want to draw a graph where we are expressing concentration of products, right, and time here, so here we are going to get upward slope because concentration of product increases with time. So initial concentration is taken as C1, final concentration will be taken as C2. For C1 we will have time T1, for C2 we will have time T2. Difference of time delta T. Difference of concentration delta P. Right? This upward slope will be rate average, which is equal to delta P upon delta T, which is equal to C2 minus C1 upon T2 minus T1. Similarly, if we want to express instantaneous rate here only, so we'll consider a particular time t. We'll draw a tangent along this, enclose it in a form of a triangle. This will be dp. This will be dt, and this slope is known as rate instantaneous, which is dp by dt, that is upward slope. Fine. So let's go for one numerical. We have a reaction, this, Now in this experiment, in this reaction, the rate of formation of NO is given as 3.6 into 10 to the power minus 3 moles per liter per second. And we need to calculate number 1, rate of disappearance of ammonia. Number 2, rate of formation of water. So how we will go for this numerical? Now we are aware of rate of the reaction can be expressed in the terms of reactants as well as products. So if we are writing in terms of reactant, it will be minus 1 by 4 this 1 by minus 1 by 5 this 1 by 4 nitrous oxide, 1 by 6 water. Now we are provided with rate of formation of NO. So we need to find out rate of disappearance of ammonia. So we can take this data and as well as this data, and we can equate the data. So minus 1 by 4 ammonia 1 by 4 TNO upon dt, right? That means this can be cancelled. So rate of disappearance of ammonia will be equal to rate of formation of NO, that is 3.6 into 10 to the power minus 3 moles per liter per second. Similarly, now we need to find out rate of formation of water. So second part can be calculated as, we can take this and this can be equated with rate of formation of water. So this is equal to 6 by 4 TNH3 dt. So this is 6 by 4 into 3.6 into 10 to the power minus 3. That is equal to 5.4 into 10 to the power minus 3 moles per liter per second. So now I am giving you people one numerical. You have to solve it on your own. I am giving you the answer also. Just tally the answer later. The equation is 2a plus b gives 3c. Here, the rate of appearance of C at time t is 1.3 into 10 to the power minus 4 moles per liters per second. You need to calculate number 1, rate of reaction, number 2, rate of disappearance of A. Fine. So answers will be, for rate of the reaction for the first part, the answer will be 4.33 to 10 to the power minus 5 moles per liter per second, and for the second part the answer will be 8.67 into 10 to the power minus 5 moles per liter per second. Try to solve the numerical, you will get the answer. If in case you will get stuck, just let me know. So now let's quickly go with another topic, that is factors affecting rate of a reaction. Number 1, concentration of reactants. The rate of a reaction is always directly proportional to the concentration of reactants. So rate is directly proportional to the concentration of reactants. Number 2, temperature. Again, rate of a particular reaction is directly proportional to the temperature. Moreover, for each 10-degree rise in temperature, the rate of the reaction becomes just double. Number 3, nature of reactants and products. Rate of a reaction is related to the ease with which specific bonds are always broken or formed. Number 4, presence of catalyst. Catalyst enhances the rate of the reaction for most of the cases. Number 5, surface area. Larger the surface area, larger will be the rate of reaction. Number 6, exposure to radiations. Rate of reaction always increases by use of certain radiations. So these are 6 factors which affect rate of a particular reaction.